All right, well, welcome everyone. I am JJ. Let's tackle an example problem. So we have today our tension in cable BC is 1,400 pounds. Let's determine the moment this cable's tension will be causing about point A. We're going to give it as a Cartesian vector and then also give its magnitude. It's a couple things for us to get through as we do this. And then we're given the coordinates for everything, for A, B, and C. Just don't move everything along. So if we're looking for moment, we should know for moment we're dealing with MA in here. My moment, MA, as a vector is going to get me, well, I need a force vector in here, and I need a position vector. I'm going to tackle this with a cross product. My position vector should go from the point I'm taking moment about to any point on my force vector. So I could either do this as R, A, B, crossed with F, B, C, my force vector. That force goes from B to C. That's the only force vector we should be using here. Or this would be the exact same thing as R, A, our vector. We could also go from A to C. That's also a point on our force vector. RAC crossed with F, B, C. Two options for us to work with in here. We'll actually set both of these up just to really drill home. This does get us the exact same end result in here. Either way that I do this, I need to find FBC. Actually, let's find all of these vectors first. So what's RAC? RAC should be, well, a vector that goes from A to C down here should be the coordinates of C minus the coordinates of A. This is C minus A. Or that will get us 20 minus 5, 15I. 15I. 14 minus 4 would be plus 10J. Plus 10J. And then 6 minus 6 will get us plus 0K feet. And we can repeat that for RAB. RAB is a vector that goes from A to B. That should be then my coordinates of the tip, B, minus the coordinates of the tail, A. So B minus A. 8 minus 5 is 3, so 3I. 6 minus 4 will be plus 2J. And 30 minus 6 would be plus 24K feet. To get my force vector set up, I'm going to be able to say that my force vector, FBC, is the magnitude of my force vector times, really a unit vector, UBC. But that unit vector is a position vector that goes from B to C divided by its magnitude. So we could write that as FBC times RBC divided by the magnitude of RBC. So let's just find each piece in here. That position vector. Actually, let's get FBC stated real quick. FBC, we know this one. It was given. Its magnitude is 1,400 pounds. 1,400 pounds. From there, let's get RBC and its magnitude. Our position vector, RBC, is going to be, well, we're going from B, the first letter, to C, the second letter. So I want to come in and do my coordinates of C, the tip, minus the coordinates of B, our tail in there. So 20 minus 8 will get me 12I. 12I. 14 minus 6 will get me plus 8J. Plus 8J. And then 6 minus 30 will get me minus 24K feet. And I can find my magnitude of this. My magnitude should be, my magnitude of RBC is the square root of my I component squared, 12 squared, plus my J component squared, 8 squared, plus my K component, 24 squared. Or solving that out, I'm going to find that my magnitude here is 28 feet equals 28 feet. Which gets me everything I need for my force vector. So let's go ahead and find that really quick. FBC as a vector is going to get me to, let's take the two constants, 1400 and 28. We'll factor them out. 1,400 divided by 28 times my position vector times 12i plus 8j minus 24k. Or this force vector is going to end up being FBC is 600i plus 400j plus 400j minus 1,200. 1,200k, and I'm in pounds because that was my force vector units. Pounds. But from here, what do I need to do next? I can start setting up my cross products. Again, we're going to make two of these. We'll get them. Let's try one here. My moment at A, MA, is going to get me to, we're going to make a matrix out for this. So one piece in here is going to be my my position vector, my moment arm vector. So I'll use RAB in the top one, RAB crossed with FBC. FBC. And then down below, we'll do this again and say, let's make that a second time. Let's actually pull that over into the corner to save some room for the magnitude. This is the same thing as saying MA equals, and this one we'll set up RAC crossed with FBC. Again, these two matrices, when we make them, we'll evaluate and give us the same thing. We just got to go through the work on it. But my moment at A is going to get me, I know my top row, I always just put in I, J, and K. My second row, I'm going to fill in RAB. RAB I got was 3, 2, 24. 3, 2, 24. And my force vector was 600, 400, 400, negative 1,200. For my second matrix, when we set this up, I still have I, J, K on the top. I, J, and K. On my RAC row, I would have, RAC was 15, 10, 0. 15, 10, 0. And FBC is the exact same. 600, 400, negative 1,200. Negative 1,200. So this can get me to this equals for either one of these, and we'll do these one at a time. Let's get our I component in here. So I, not an I equals, this is I times something. But I, if we work with our I component, I look at just the J and K pieces in here. So 2 times negative 1,200, our top left times our bottom right, minus, not plus, always minus, top right times bottom left. 24 times 400. We then subtract out J every time. And now we look at our I and K pieces. Top left times bottom right. 3 times negative 1,200. Minus our top right. 24 times bottom left. 600. Minus 24 times 600. And then we go back to adding for our K. Plus K. For the K piece, I work with just I and J. So the top left would be 3. Bottom right would be 400. So 3 times 400 minus our top right times bottom left. 2 times 600 minus 2 times 600. If I look at the bottom matrix in here, that same process again is hold true. My position vector is different. My actual answers when I work those out are going to come out to be the exact same thing though. So if we go with our I component, again, I times, not an I equals. But I now have, looking at the J and K, 10 times negative 1,200. Top left times our bottom right. Minus top right times bottom left would be 0 times 400 is just 0. We still subtract J, so minus J times, now I look at the I and K. Top left is 15 times our bottom right is negative 1,200 minus 0 times anything is 0. So just minus 0. And then we go back to adding one last time. Plus K times, look at the I and J. 15 times 400. 15 times 400 minus, let's actually make that a little bit nicer. 15 times 400 minus our top right times bottom left. 10 times 600 is going to get me my K piece. Either way in here, I'm going to get that my moment as a Cartesian vector is, whether I approach that as 2 times negative 1200 minus 24 times 400, or just 10 times negative 2,200 or 1,200. We get the exact same thing. This is negative 1,000 or 12,000 I. Whether on the J I do negative times 3 times negative 12,000 minus 24 times 600, or 15 times negative 12,000 and make that a double negative. I'm going to get here plus 18,000. J. And again, no matter which set of numbers I work with in here, I'm going to get the same K piece. This is going to give me to 0. 3 times 400 minus 2 times 600 is 0. 15 times 400 minus 6,000 is also 0. Plus 0K. Or we could just leave the K piece off. That would be our force units, pounds, times our distance units, feet. So we'd be in pound feet for our moment as a Cartesian vector. Again, exact same answer coming out here, regardless of which of my two moment arm vectors I got. As long as it goes from the point I'm taking moment about to some point on my force vector, my answer works out to be the exact same. On my last step in here, I need to get my magnitude of MA, which my magnitude should be the square root of my x component squared. I'm going to drop that negative, because negative 12,000 squared and positive is the same thing, but it makes so I don't get a weird calculator error. Plus my j component squared, 18,000 squared. Plus 0 squared is still just 0, so leave it at that. And I can solve this for MA. My final answer in this problem is going to be that my moment about my fixed support is 21,633.31 pound feet, which would be our final answer for our problem. Again, we're really just doing the cross product in 3D to get through our 3D moment problems. But hopefully this is a useful video for you. If it was, stick around, watch more videos, hit those like and subscribe buttons. Let's get you in with JJ.